perspective and groundwork for our future, for our further speakers to build on. So thank you very much for sharing time with us and doing this session. Uh, uh, this brings to our next presenter, an expert who, as I said, is a thought leader and a known person in this space. I would now like to invite Dr. Mritunjay Chaubey, Global VP Environment Sustainability and Green Cell at UPL India Limited. And he's going to talk about the standards of the comprehensive industry documents for pesticides industry proposed by the CPCB. Most importantly, he's going to be doing a critical review of the document as proposed by CPCB. So over to you, Dr. Chaubey.
Thank you. Thank you. So I shall, am I audible?
Yes, sir, you are.
Okay. So here in a brief presentation, I shall share comparison, means mainly from the industry side, that where we found that the draft comprehensive industrial document for pesticide industries, maybe 1.5 years back, it was released by CPCB. Still it is at a draft stage, and number of time discussion happened with the CPCB, and I also used to participate on behalf of CII, sometimes Indian Chemical Council, and PMFAI. So several industrial associations, they have represented their grievance on the comprehensive industrial document for pesticide industry. So in short, it is called COINDS, and CPCB has released this draft 1.5 years back. And if you go through the draft document, it is a long document, and several things are good also, because with passage of time, we have to revise the standards, we have to brought several things in. So several things are good also, but on mainly 4 or 5 points, we have already put our view in front of Central Pollution Control Board, that they should again review, and discussion is on. So those points are, first is on COD. So existing standard, if you see, then for pesticide industry, it's 250 ppm COD limit to discharge on surface water. Whereas the new proposed document is coming with 150 ppm. So there our point is that even 250 ppm achieving COD in a treated wastewater from pesticide industry is a difficult task, and it's not easy task. And I think we should make our standard practical and achievable. And right now the industries are struggling even to bring down less than 250 ppm. So at this point of time, we should focus that at least 250 ppm people used to achieve inside industries, rather than making it more stringent 150 ppm. Another supporting point we have raised, that why there should not be revision in COD, because if you see the international standards, we can see the US EPA standard, we have European standards, we have standards in China, and also developing countries. So they also, if we see for pesticide industry, they are higher than 250 ppm. Even at this moment of time, if we refer US EPA standard, which are for the deep sea discharge, there for pesticide industry, they have limited for deep sea discharge as high as 4000 ppm. So our point is that it should be kept as it is, 250 ppm. It should not be reduced to 150 ppm. Second thing is on BOD. So proposed standard is saying that the BOD should be less than 30 ppm. but the existing standard, if we see for pesticide industry, it was kept 100 ppm. Because inside pesticide industry, if you see the effluent, then in treated effluent, although we able to achieve 250 ppm COD, but it's very difficult to achieve BOD less than 100 ppm. Then arsenic from 0.2 ppm, the new standard is saying that it will be 0.1 ppm. Next one is copper. On copper, right now it is allowed 1 ppm. The new standard is saying that it will be 0.5 ppm. So these about the discharge standard. The last point where I think the maximum grievance is there from the industry and our discussion going on with the Central Pollution Control Board is effluent generation. So if you see the proposed COINDS standard which has come from CPCB, it is saying that the wastewater from the pesticide industry discharge should be limited to 220 liter per ton of production. Presently, there is a no limit, no standard on the quantity, discharge of quantity of effluent from the pesticide industry. But this new COINDS, the new standard which has came, they saying that the pesticide industry must discharge effluent less than 220 liter per ton of production. That I think that it is not a practical, because at UPL we have a globally plant, we have presence global, and we have several manufacturing plants within India, outside India, Europe, US, Colombia, Netherlands. And what we found that average, if we see maximum, minimum, all average together in pesticide industry, then it is coming between 3,000 to 4,000 wastewater per ton of production. So if average wastewater from pesticide industry is coming 3,000 to 4,000 liter per ton of production, then how it is possible to limit to 20 liter per ton of production, unless until we go for the ZLD. So if we go for ZLD, then that is a different approach. But if they allow for the discharge after treatment, then 220 liter per ton of production is a very, very less and not practical. And at this moment, none of pesticide industry achieve this. So that point we have already raised to CPCB, and the officials are looking into it. Discussion is going on. Still it is at a draft level. So I think this is the main point. A part of this, there are several other points, but those are not critical, and more or less we are okay. And only these 4 or 5 points where our discussion is going on. So this was about these points. Now I will take this opportunity to also narrate some of the problem in the wastewater treatment comes in pesticide industry. And it's not only pesticide industry. In all the complex kind of industry, especially chemical industry, agrochemical or pharma, the major problem is the variation in the effluent characteristics. So always there happens to be variation in effluent characteristics, and also the presence of TDS. And when the higher TDS comes in effluent, then the biological treatment doesn't work well. And at UPL, what we have done, and that I want to share with the all audience, that one thing we have done is we have adopted a good practice of effluent stream identification, characterization, segregation, and then treatment. And that's help us a lot. So I suggest that those who have problem in operating the effluent treatment plant because of complexity of effluent, they should adopt effluent stream identification, characterization, segregation, and treatment. And mainly at UPL, we have identified 3 streams, green, yellow, and red stream as per the TDS level, and we have given appropriate technology. Another good thing we have done, we have created a green cell inside UPL, and at a green cell, we have a lot of engineers, biologists, chemists, and their only work is to work on the green sustainable technology and deploy inside UPL such that we can treat our wastewater well, and also we can achieve zero liquid discharge, and also we can reduce our environmental footprint. So that also help us a lot. So technology and technical manpower is a very key for the success of wastewater management. So I think with that we will go for the question answer session, and so fine, it's open for the question.
Thank you, Dr. Chaubey. So I do have 2 or 3 questions, that have come from the audience. So one is that, it's a generic question from Hari Singh from IIT Dhanbad. How do you reduce the cost of advanced industrial wastewater? So, Dr. Chaubey, would you like to take that?
Yes, yes. So actually regarding reducing the cost of wastewater management, we did a lot of work at UPL, and I told in my opening remark that we have created a green cell at UPL, and they work on deploying sustainable green technology, number one. And second is we work a lot on the effluent stream identification, characterization, segregation, and treatment. And what we did, we separated all the stream into 3 streams. One is a green stream where TDS is below 5,000 ppm, and very easily we can treat with the biological treatment. Then we identified second kind of a stream, yellow stream, where the TDS is higher but less than 1 lakh ppm and slightly difficult to treat. So there we deploy some of the technology like OH radical or forward osmosis. Also we used a scale band technology to recycle the water into the cooling tower, and we treat well. And the third stream we identified as a red stream where TDS are beyond 1 lakh ppm, and there we have given appropriate technology and handled it. So I think by this way, you will find our experience at agrochemical companies at UPL is this, that nearly 50 to 60% effluent comes as a green, which easily it can be treated at very less cost, and 20 to 30% are yellow, which slightly costly, but it should be segregated and treated. And last, red stream 10%, which is costly to treat because there we have to deploy costly technology, but only 10% quantity happen. And if we can segregate, then we can treat well. And if you see the overall cost, then cost will get reduced. So these kind of a strategy help us a lot to decrease the wastewater treatment cost. Second strategy we adopted is using a scale band technology where we can recycle and reuse treated wastewater inside the cooling tower. So that also help us a lot.
So, Dr. Chaubey, I have one more question from Neeraj Nautiyal from BPSL. He is asking a specific question saying, how do we reduce the consumption of water in steel and power plants?
So I think in order to reduce the water consumption, I especially feel, based upon my 24 year of experience inside industry, first thing is needed is a targeting. Means we must have a agreed target, and it should be derived from the top to bottom that we have to reduce so much percentage of water consumption. And if we have willpower, then we will able to do. Because I have seen it when I was in Unilever. I was 5 years in charge of sustainability of Unilever, and we reduced 50% water consumption inside the manufacturing plant of Unilever globally. At UPL, right now we are driving to reduce the water consumption, and we have set a target in 2016 that by 2020 we will reduce 30% water consumption inside UPL manufacturing plant, and we did it. Even we achieved more than that. So first thing is set the target, have a willpower, and it should be derived from the top to bottom. Second is technology. We have to adopt the technology. Like one technology, I tell you, a scale van. So even in power plant, when the effluent comes, treated effluent, you can recycle 100% treated water with a scale van technology into cooling tower. And you can recirculate the water as high as up to 2,50,000 ppm. So huge water can be reduced in cooling tower, and in power plant, I think the main water consumption is in cooling tower. So there we can able to reduce the water. A part of this, if we can utilize the rainwater, because at UPL we have derived very rainwater utilization. So our strategy is not to take the rainwater and harvest inside the ground. We always used to store the water, collect the rainwater, and we utilize inside the plant after giving proper treatment. We don't send to the ground, and that strategy helped us a lot. It saved a lot of water. I think day by day I used to track the total rainwater used inside operating plants in India. Today figure is saying that in this rainy season we have used 50,000 cubic meter rainwater inside our 4-5 big manufacturing plant at UPL. So that is also one strategy where you can save the abstracted water demand.
So we have started getting a lot of questions from the audience. So Dr. Sontakke, we have a specific question for you from Mr. Manu Gaurang from Thermax Limited. He is asking a question, should ZLD plants be subsidized by the government and banks to encourage its use? Dr. Sontakke?
Basically, it could not be subsidized directly, or it can be given some incentives by way of the conserving the water, and at the same time it can be incentivized in way of the minimization of the water charges. But directly we could not go for that because it's a part again how much because calculating the ZLD and its benefits, because all the benefits are going to the industry particularly.
Dr. Sontakke, one more question to you from Ms. Mansi Shah. She's asking, is there a pricing policy for reclaimed water in Maharashtra?
Till this date, we are trying for that, but not yet declared, or it is in process of the finalization.
Maybe this question could be either taken by Dr. Sontakke or Mr. Chaubey. The question is from Sachin Malekar. He's asking, is the polluter pays system really working in CETPs?
Yeah, definitely. The polluters pay principle is working, and nowadays the CETP is also charging based on the what pollutants they are discharging to the CETP. It was earlier notification, but later on we have taken some of the modification in that, and how much potential that water or that effluent has to create problem in the nature. Based on that, the polluters pay principle has been newly modified.
Okay. Dr. Chaubey, a specific question to you from Tarun Gurnani is that what is the methodology for treatment of copper and arsenic removal in UPL?
So actually, if you see our effluent, we don't have problem of copper and arsenic. We don't face any kind of problem in wastewater, especially copper and arsenic.
Dr. Singh Gupta and ex-director. Yes, Dr. Chaubey.
But I think this arsenic problem, normally wherever it happens to be, it can be treated even several times when in primary treatment we dose the lime. So when we do the treatment of primary effluent with the lime treatment, then also we solve the problem of arsenic.
Dr. Chaubey, there is a question to you from Dr. Sen Gupta, who was an who was working with the CPCB. So he's asking, what is your opinion about ZLD?
Okay, so I think my opinion is not very good on ZLD because I especially feel we have done number of feasibility study, and I personally feel that when we do the ZLD, then it create more problem than solving. And you will find a lot of carbon emission happens because a very energy incentive process, if you want to achieve ZLD, then it will be not done alone by just deploying a reverse osmosis system and recycle reuse. 30% nearly reject water comes, and we only end with doing the evaporation with the multi-effect evaporator. So when you say ZLD, then you must have to look for the equipment like ME or evaporative technology. And you know, when we use evaporative technology, then huge amount of energy get consumed and CO2 emission happen. And today the world is facing a difficult situation, and the main issue is the carbon emission. And when we will deploy ZLD, then we are going to increase that problem. Our study show that suppose we have did the one study with our agrochemical industry recently, and what we did, we compare two things. One is we have ZLD plant because at this moment of time, 60% our plants are zero liquid discharge. So we did the study that when we just meet the CPCB discharge standard and discharging it, what is the situation? And when we adopt the ZLD or achieve the ZLD, then what is the situation? We found that when we do the ZLD, as compared to just simple treating to meet the discharge standard, carbon emission is 4 times higher, and solid hazardous waste are 2.5 times higher, and overall operating cost also happens to be nearly 3 times higher when you go for the ZLD as compared to just treat as per discharge standard. So I think a detailed study we have published in Indian Chemical Council journal also, and my view has been very well published there, and that document can be also referred. So in short, I can say that I am not for the ZLD. ZLD is only good in those areas where there is no proper discharge mechanism and no discharge lines are there. Very huge water scarcity is there. Then fine, you can go for the ZLD. But if you have discharge facility, like in Gujarat coastal area, we have very good deep sea discharge facility. So they are going with the ZLD. I think it's not a nice and not a environment friendly approach.
I would now like to bring in Dr. Johann here. He is our international expert. So, Dr. Johann, your views on ZLD, the trend you see globally, would you be strong? You want?
Yeah. Good afternoon, everybody, and thank you for having me at this webinar. Yes, I mean, the ZLD is always an interesting question because of what the previous speaker shared. These are valid points, and it is technologically possible to achieve ZLD. So from a technical point of view, yes, we have the technologies, as mentioned, we have the evaporators after the RO to concentrate the brines and crystallize the brine. So that's technically possible. But so far, in most cases, it is not economically viable. Yeah, environmentally, yes, it has more carbon footprint, but we can get away from the environmental part by using renewable energy. So in some parts of Europe, for instance, you can use hydrogen energy, green hydrogen energy. You can use solar energy. If you have solar energy in Middle East, you have that potential. In Australia, you have the potential. So on the energy supply point of view and environmental point of view, yes, you can minimize the impact, but the economics are still higher compared to treating and reusing and not going to a full ZLD. Just to give you an example, the cost of recovering 95% of the water from a water treatment plant with reverse osmosis and so on, the cost of recovering 95% is half the cost of a ZLD plant. So just to go to that 5 level, the extra 5% recovery, it costs you double the amount that you will spend for 95%. So it's not yet economically viable, but with new advancements in technologies using green energy, I think in the future we will get there.
I would now also like to bring in our other speaker, Colonel Bhaskar Tatwawadi. Sir, we have a specific question from Kalpesh Kothari, if you would like to take it. He is saying that in the edible oil industry, sludge generation is very high. Can you give us some suggestions on, addressing the same? If you can unmute yourself. Sir, if you can unmute yourself. No, sir, I cannot hear you. While we are solving, sir, we cannot hear you, sir. So till we solve that, I will go on to another question. Dinesh Chand has a specific question for Dr. Chaubey. He's asking, what is the procedure for waste generation by arsenic water treatment? Sir, would you like to take that?
No, what is question? Wastewater generation from?
No, so he's asking, is there any kind of, solid waste at UPL, and what are the technologies there to treat that?
Solid waste, yes, on solid waste, we have done a lot of work. And first thing on the dewatering technology, we have installed one technology called Volute, and we found very good because Volute consume very less energy, very less chemical, and also it is a compact system, 24-hour you can run. And for the dewatering of sludge, it is a very good technology we found and we have implemented at UPL. A part of this, I think if we want to reduce the solid waste, then we have to look at the source. And at source, suppose in wastewater treatment plant, if our treatment is basically a chemical treatment, where we used a lot of chemicals and then treat the wastewater, certainly you will go to end with the generation of huge waste from your wastewater treatment plant. So we have to change our strategy of treatment. We should try to adopt less chemical treatment in wastewater, then we can reduce a lot of waste generation from the wastewater treatment. Similarly, from the manufacturing plants, we get the waste and we don't focus on the moisture removal. Several times, people generate the waste having moisture content 90%, 95%, 85%. Then certainly because of more water content, volume of waste go on increasing. But if we deploy their drying technology and we can brought down the moisture content below 25% or 30%, then we will reduce the quantity of waste generation and very easily we can send to the suitable site for the disposal. So I think these all are the way by which we can reduce the waste generation inside manufacturing plant.
Okay. Colonel Tatwawadi, are you back? Can we take up a question for you? Colonel Tatwawadi, can you hear me? I think we are still, facing.
He is muted. Now he is on.
Colonel Tatwawadi, can you hear me? Can I take a question to you, sir?
Sound is not coming.
Okay, I think. Yeah. So what we will do is, while we are, solving his problem, I have a question that could either be taken up by Dr. Sontakke or Dr. Chaubey. Sir, the question is from: is ZLD possible in pulp and paper industry?
So should I take? I think better.
Okay, sir, you take it.
Okay. So actually in paper and pulp industry, I especially feel that a huge wastewater gets generated. And we can think there to deploy technology where we can do the maximum recycling and reuse. But just to meet the ZLD, this is a costly affair. And today the paper and pulp industry, from economic point of view, if you see, especially they are facing the problem. And if we will press ZLD for the paper and pulp industry, then I don't think their manufacturing cost is going to compete inside the market. So better they should treat well, they should reuse and recycle maximum amount of water, and then finally those water which is not possible to recycle, reuse, they should discharge after giving proper treatment, because they generate a huge effluent, and making it ZLD, it will make them uncompetitive.
I am agree with Mr. Chaubey. Basically, recycling is not possible in case of the pulping industry, but it is possible in case of the waste paper processing industries, because those industries which are procuring the waste paper, and it will be pulped and reused. Means the entire water quantum can be reused, and this type of the 65 industries are operating in Maharashtra, and they are really doing well. But only problem with, as Mr. Chaubey has quoted, that pulping industry, it is very difficult for them to go for the ZLD, because the high cellulosic matter which is generated and it has high COD, so it is very difficult to go for the ZLD economically. Because
Dr. Chaubey, he is asking, is the MBBR technology suitable for industrial waste?
So yes, for biological treatment, especially if TDS of effluent is less than 5,000 ppm, then MBBR is very good. And our experience with MBBR technology is very good, because it is a compact technology. It reduces the area occupancy, also the purification efficiency enhanced, less energy consumption happen. But the only issue with MBBR is that when the TDS is higher than 5,000 ppm, then it's get the all MBBR media, the scaling happens on the media, and finally it sink down. So that should be taken care. If TDS is less than 5,000 ppm for biological treatment, MBBR is a much better technology than normal activated sludge process.
Sir, one more question for you, Dr. Chaubey, from Mahendra from Grasim Industries. He is asking, what is forward osmosis?
So forward osmosis is a new technology, and recently we have implemented at UPL. This is a technology which work on the principle of forward osmosis. So it is just reverse of reverse osmosis. And I think if I can say in simple word, it's consume less energy as compared to reverse osmosis, but it handle high TDS. Suppose if you deploy the reverse osmosis, then if TDS is more than 10,000 ppm, then you will face problem because seawater membrane you cannot deploy in wastewater treatment, and the brackish water have efficiency just to treat below 10,000 ppm. Second is if COD or organic impurities are coming, then the RO get fouled. Forward osmosis is a improved version of this. Even if COD is coming and the TDS is higher, maybe even 50,000, 60,000 ppm, you can treat the wastewater with lesser energy consumption with forward osmosis. Actually, it uses the principle of a drawdown solution. So the technology provider used to provide drawdown solution, which is based upon your characteristics. So they used to study your effluent characteristics, and then they recommend the drawdown solution, and then the forward osmosis works. So we have a good experience. We recently deploy inside UPL forward osmosis to treat the high TDS and moderately high COD, and it's working well.
Sir, one more question from KP Gwalani from Cool Deck Industries. He's asking, can you give us the advantages of the use of MBBR and tube settler media?
So actually both MBBR we used at aeration stage. So inside the aeration tank we use MBBR media, and after that at place of secondary clarifier we use a tube settler. And when you use MBBR and tube settler, advantage is this. First advantage I can say that it saves a lot of area occupancy. Today in industry, when the all manufacturing plant are there, a very less area available for the wastewater treatment plant. So this technology offer a solution where you can have a compact system, and within very less area you can install the MBBR and tube settler. So number one advantage. Second advantage is your purification efficiency get enhanced. So wastewater treatment plant give better result than normal conventional system. And the third advantage is area energy consumption. Power consumption inside the wastewater treatment plant reduced. Because MBBR also there is a reduction of energy consumption as compared to conventional activated sludge process. And in tube settler, since there is a no moving part, so 100% it is energy and power free system. So I feel that if you compare with conventional system and MBBR tube settler, then you may end with saving nearly 40 to 50% energy also. And the last advantage I will say, less sludge production. So normal conventional system used to work on the principle where large recycling and the large wastage of sludge from the biological reactor happens. So it ends with the huge sludge generation, whereas in MBBR tube settler, you will get a very less sludge production. So these all are the advantage of this technology.
Thank you, Dr. Chaubey. I have a question for Dr. Johann now. Raju Gupta from IIT Kanpur is asking this question, Dr. Johann. What are the treatment options for emerging contaminants in wastewater?
That's a very good question. So we didn't talk much about these technologies for removing contaminants of emerging concern, as we call them nowadays. And these are pharmaceuticals, organic micropollutants, and pesticides that we see in the water. So normally we go from, in recent years, we have focused on what we call phase changing processes, which includes adsorption, activated carbon. So we can put the activated carbon either as a granular activated carbon in a bioreactor or activated carbon filters. And membrane processes also have been used to remove those contaminants. We are doing a couple of projects in the Netherlands where we're looking at biological removal of these contaminants of emerging concern. But the best technologies today, from my point of view and from my experience, is advanced oxidation processes. So based on UV and ultrafiltration, ultraviolet systems, UV and hydrogen peroxide, or UV and ozone. So advanced oxidation processes are the most, to my knowledge, efficient technology to remove those type of contaminants.
Thank you, Dr. Johann. Colonel Tatwawadi, we have a question from Varun Prabhu. He's asking, what is the comparison between biological treatment and Fentanyl treatment for textile industry?
So I am hearing about the Fentanyl treatment for textile industry for the first time. My experience is about the biological treatment, which is extended aeration and extended aeration for a duration of about 72 to 84 hours. And Fentanyl treatment I am not aware of, so but I will look it up and then maybe I will be able to answer later.
Okay, sir, I will send the questions, to you later. Dr. Chaubey, Raj Mehta is asking, is the Beckenbauer system beneficial for cooling water instead of chemical treatment?
So yes, it is useful and lesser chemical needed in this technology, and we have also certain system at UPL. So definitely it helps.
Okay. Colonel Tatwawadi, a question for you is that in the textile industry, do you think ZLD is a promising option?
ZLD has never been a promising option for the simple reason that the evaporation of reject or evaporation of wastewater which is left out even after recycle or reuse is a huge cost on the industries. And around in the last decade, the cost of evaporation of wastewater per kiloliter used to be approximately 400 to 500 rupees. And that is a big cost when it comes to ZLD. And with the best possible process options which we have today, including the reverse osmosis, the quantity of reject, which has been minimized to about 10% of the overall, input to the treatment plant for 1 MLD to 100 KLD, which is the minimum reject which needs to be evaporated either by the solar evaporators or by using the other energy, power. So power input for evaporation is a huge cost, and that is why ZLD is an ideal goal, but it is more of a utopian goal than any a practical solution to the textile industry.
So one more follow-up question to that, Colonel Tatwawadi, is can we use ozone treatment as tertiary treatment for color and COD, BOD removal?
Yes, very much. In fact, I have visited a few plants which were using ozone for not for color removal, but generally for oxidation. use of ozone for oxidation or for color removal or advanced oxidation involves firstly the installation of a ozone production plant, and secondly ozone is a very strong corrosive agent, even stronger than chlorine. So sometimes in the process, there may be requirement to strip the effluent of ozone. So these are the two issues with use of ozone. As against that, the other processes like the membrane bioreactor and the reverse osmosis, in their use as the process regime, there is no such problem. But yes, ozone is an option, but I have not seen ozone being used on a large scale for color removal in the textile industries, and I have visited several hundreds of them. So,
Dr. Sontakke, a question to you I have from Mr. Shakil Shah. He's asking, is there a minimum or a maximum quantity of industrial wastewater that can be discharged to a government central treatment facility?
Basically, the CETPs, because he is asking for the CETPs, and CETPs are based on the quantum and quality and quantity of the member industry. So, while designing any of the CETP, that time it has been taken care that how many industries of what quality they are contributing to that plant, and based on that, the design is made. And with that design, the DPR is prepared and it is put into the execution. So therefore, what design they have made to get the inlet quality as well as quantity, based on that, it will be permitted. If suppose one industry is having the 100-meter cube and CTP is having the capacity only 50, then that could not be accommodated further. But prior to the designing, it can be accommodated, and accordingly it is planned in the state of Maharashtra.
So one more follow-up question to that is that he's asking is that if there is an industry producing a certain X amount of water, are they allowed to discharge to the central wastewater treatment facility, or do they have to first treat it and bring it to a certain criteria?
Basically, we are having the two models. Number one model is the inlet design criteria, because that is based on the what DPR is initially prepared, and based on that, the characteristics of the each industry is fixed. What industry should discharge what quality and what quantum. That is based on that the CTP is designed. Another part, another type of the CTP may come, that inlet design may be the at tail end. Means entire quantum untreated can be reissued at the CTP, and CTP will take care that it will be treated. But this is a very dangerous part. If suppose one industry having the 10-meter cube with the several lakhs of the dye intermediate or some of the pharma intermediate industry, and they are discharging 2 lakhs COD to the CETP, could not materialize. That's why all the CETPs have the inlet design parameter based on the quantity as well as quality. Otherwise, CETP could not function, and that will be duly checked while receiving the effluent to the CETP.
Dr. Johann, this is a question that I get in every webinar around wastewater. So the question is that are you aware of any studies in the Europe which show the transmission of coronavirus through wastewater?
You're probably aware that KWO Water Research Institute has been the first to detect coronavirus RNA residues in sewage wastewater. So we have done, or we're still doing, a lot of studies, but it is all related to domestic wastewater, not to industrial wastewater. So there are many studies, many publications, many insights that you can find on our website on what we have done on coronavirus and sewage. How do we track the residues of the virus in wastewater that can give us an early warning system much earlier done clinical testing. Clinical testing, as you know, will take up to 1 week or maybe more, 7 to 10 days before you know that you're affected by the virus. But when you analyze wastewater, domestic wastewater, within 48 hours, we will find the residue of the virus in the wastewater, and we can give that early warning to authorities that this area or this catchment has been affected by or infected by the virus. So most of the studies are in domestic wastewater, and there's plenty of information on our website. Please go there for more.
Thanks, Dr. Johann. A question, Dr. Chaubey, to you from Nilam Nalawade, who is from Khilari Engineering and Construction Private Limited. The question is, how inlet wastewater TDS is less than treated water?
So I think this is very interesting question, and we also came across this, and this surprises the people, because when the TDS, how the lesser TDS in the inlet, and at the outlet you end with the higher TDS. So it's happened, one is slight increase in the TDS happen because of in primary treatment when we dose several coagulant, flocculant, then also we end with slight increase in the TDS, but not much more higher. Normally higher TDS comes. Why? Because at a tertiary treatment, people have tendency to use more hypo solutions. Means they do more chlorination. When they don't get the result from the aeration tank, desired result, then they dose more at the tertiary level hypo solution, especially for the ammonical nitrogen. If today you will see, our standard norm is saying that ammonical nitrogen should be less than 50 ppm. So to bring down ammonical nitrogen within the limit, people dosage high dose of hypo solution, and when you dose the high dose of hypo solution, you able to achieve the COD reduction, you able to achieve the reduction of ammonical nitrogen, but you end with increasing the TDS, and that's happened because of that one.
One more question to you, Dr. Chaubey, from Gloria Alanis from AWA, is that what is a one method new for disinfection?
So one method is the chlorination, what I told right now, dosing hypo. This is a general method industry used to follow the practice. But yes, when you dose high, then you end with the increase in TDS. The other method is UV, ozonation. Nowadays, OH radical technology is also used to disinfect the wastewater. So several technologies are there. I think the UV, ozonation, these are nowadays prominent than chlorination.
Colonel Tatwawadi, a question to you from Om Prakash Kumawat from MLV